Hello, I'm Nancy Gregory. Welcome to the Future of Cyberspace by Brightword Books, where we explore tech, society, and democracy in the digital age. Today, we're diving into the fate of AI society, civilizing superhuman cyberspace by Kenneth J. Hamer-Hodges, unpacking cybercrime, AI threats, and the fight to save our digital future. How do outdated systems and digital warfare put us at risk? And what can we do to fight back? Let's get started. Ken, thank you so much for joining us.
Hi, Nancy. It's a pleasure to meet you and to talk to your listeners.
Oh, we look forward to this conversation. To kick things off, can you tell our listeners a little bit more about yourself?
Well, I graduated a while ago in 1966, believe it or not. Back in those days, you couldn't buy a computer, you couldn't buy software. There were no operating systems. To use computer science as we wanted to in the telecommunications industry where I worked, you had to build it from scratch. And the telecommunications industry is different from computer science. The computer scientists built batch processors that only needed to work for an 8-hour shift. For telecommunications, we wanted to match the existing technology that lasted a lifetime. The public utilities demanded reliability from their computers. So we had to meet mean time between failures of decades, many decades, 50 years, for example.
Wow, yeah.
Whereas a computer only needed to work for 8 hours, and then they could wash it clean and start again the next shift. And those computers that we designed in the 1960s are still in use today architecturally. They may have converted into silicon, and they may be a fraction of the cost and a fraction of the size, but they're still the same batch processor design of the physical world that ended World War II. In those days, we didn't understand software, and we didn't understand that we're transitioning from a physical world into a world of information. And therein lies the rub.
Can you give a quick summary of the fate of AI society?
The fate of AI society is I tried to write for the common man who has no degree and no understanding of computer science. It's the computer science is complicated because it is living on this world between the physical world and the abstract world. And unless that junction is engineered, we have what we have today, chaos. So I try to explain my concept of industrial strength computer science in terms that everybody can understand. And the reason why is that as a democracy, if we want democracy to survive, everybody has to be involved. It's as important a fight as the Revolutionary War, the Civil War, and the Second World War. If we don't win, we will end up as a dictatorship.
You describe a vicious cycle where outdated tech fuels cybercrime. How exactly do these aging systems make us more vulnerable?
The problem is that when computers began, software was not seen as a subject in its own right. It was just an incidental. And the people who wrote it were the same people who designed the computers. If they made a mistake, they just rewrote their own software overnight and ran it again the next day. They didn't worry about concepts like data security and malware and ransomware that now pervade cyberspace and have the power to stop the world in a flash. I don't know if you remember last July, CrowdStrike issued a release that froze the world of Windows computers worldwide.
Oh, I remember that.
The industry chaos that created was traumatic and cost billions of dollars when you take it on a global basis. Thousands of computers were involved in a flash, and nobody had the wherewithals to stop it once it was released. It's like a pandemic. It's like COVID-19 in a digital world.
That's a terrifying thought. Absolutely. AI and deep fakes are reshaping misinformation. How is this impacting society, and what can we do to fight back?
Well, first of all, take nothing for granted. Anything you read on the internet is dangerous. Anything you see on the internet, now with AI and deep fakes, you can't trust anything. I saw a short video that came my way, I can't remember how, and it was clearly representing positions that nobody in the video would have sponsored. And it made so real that you can't just reject it on a normal basis.
You know, I find that interesting because my son is in high school, and in their media, he takes a media class that specifically talks about this and how careful young people need to be moving forward in making sure the information they're getting isn't misinformation.
Well, that raises another point. Whose responsibility is it to make computer science fail safe? My view is that it's the engineers. Mm-hmm. They're the only ones who really know. Government doesn't understand, and their bosses only wish to keep the market that they have. Mm-hmm. So they're not interested in fixing these problems. It's a very dangerous situation we're in, where people are denying any responsibility for it. My view is that unless we build it into the system from the beginning, as I had to do for my industry, it will never be done. And the books, I've actually written a trilogy on the what, the why, and the how we can achieve industrial strength computer science. And this is the second in that series, the why. And the vision that I see, if we do nothing, is it's inevitable that we will end up with digital dictatorships running the industry.
Well, and let's talk about that a bit more. Your book highlights how corrupt systems exploit digital governance. How does this undermine democracy, and can better cybersecurity help?
Well, to put a full stop on it, we have to follow the science of what is called the Church-Turing Thesis. It was invented 10 years before the first computers were ever thought of. And the Church-Turing Thesis recognizes this two-sided problem between logic and physics, and describes the surface of computer science, the computation, the active component, using the same science that governs nature in all its forms. It's atomic, and it's cellular, and it's dynamic, and it is something that has a life cycle of its own. And so building that life cycle into software is essential if we're ever going to solve these problems.
And you argue that hardware needs to catch up with software to prevent AI threats. Why is this gap so dangerous, and how does it impact, like, more particularly security?
Well, the fact is that software that I write or that anybody else writes is exposed in cyberspace. The binary computer has no physical laws to protect anything that's put there. The digital memory is shared by everybody. And that digital sharing allows malevolent code delivered by adversaries, enemies of the state, what I call the Crink gang, China, Russia, North Korea, Iran, work together, or not necessarily together, but collectively, to bring down democracy. So they have a vested interest in destroying what we've done. And it's so easy for them to do it because we've never put any protections in for the software that's there in the first place.
What are the most urgent steps governments and companies should be taking to make cyberspace safer and more democratic?
That's a challenging question. I've been in the industry for over 50 years, and I've spoken at significant industrial conferences specifically on this subject. And the engineers themselves are so fascinated by building operating systems and writing solutions. They can play God when they do it. And in playing God, it's addictive. So they don't concern themselves with the consequences of trying to play God. And they carry on building it that way. The bosses that run the industry are interested in the revenue that they've accumulated. And so they have no interest in fixing it. And the government just doesn't understand. So where do you turn? Democracy is driven by the people. Individuals define democracy. And just as they fought in prior wars to preserve democracy, they must fight again in this war to preserve democracy.
You envision a well-engineered, crime-free global cyber society. What would that look like, and how do we get there?
Well, first of all, I would say it's a much improved solution because it's atomically defined, like real life. We all have genes in our bodies that control how we behave. We need to have genes in cyberspace. The cellular nature of computer science needs to be driven by the cellular nature of mathematics. We teach little children A equals B plus C. These are the symbols of a pure scientific solution. And so we have to build those symbols into the hardware, into the machine code, which is the first programming language of computer science. And we can't allow the centralization of the operating system and the compilers to change the rules. We have to use the science that was developed by Alonzo Church in 1936. And he was the guy who gave guidance to Alan Turing when he defined the binary computer. And you need both Turing's work and Church's work to solve this problem.
Are there past examples of tech mismanagement or digital threats that we can learn from to avoid future disasters?
I'll give you two. As with anything else, when humanity is discovering something new, they make mistakes. And the binary computer is just one of those mistakes. But the first example that I have, when Napier invented logarithms back in 1600s, he worked for 20 years alone in Scotland, producing thousands and thousands of numbers, which he had to calculate by hand in every case. But he did it to a mathematical idea called E, which is not understood by the real world. So after 20 years, when he published his book in Latin, it was gobbled up by the whole of Europe. A gentleman from Cambridge, his name was Briggs, was so fascinated, he struggled to Scotland 2 years in a row before Napier actually died, and persuaded Napier that he'd made a mistake in using the number E, 20 years of mistakes, and that it ought to be the number 10. And so they agreed. And for 20 more years, Napier died after 3, but 20 years Briggs struggled on, producing his logarithms to the base 10. And that's what we use today because it's democratized. People can understand it. Instead of being opaque, like current computers, nobody knows how an operating system works. Nobody understands why things don't work first time when you ask them to, because everything is so opaque and complex. It is only through science that we can bring transparency. And that has to be done at the machine code level. That means new hardware. And therein lies another complicated problem. How do we move the industry from everything they're doing at the moment to something that works reliably for the future?
Exactly. And how can the scientific and engineering communities help build safer, more democratic digital spaces?
Well, I think nobody is free from it. The engineers have to design it right, but they have to be given the incentive. The industry has no incentive to do it. The problem is a pandemic on the scale of COVID-19, where the government must step in with a warp speed solution, which they fund because they have the money. The cost of doing this is a sliver of the Pentagon's annual budget. It's not that we can't afford it. It's We have to have the will to do it. And while people aren't dying in the physical sense of COVID-19, we are dying economically, and we will suffer politically by not solving the problem.
How do you get the governments involved in taking this seriously?
Well, I tried persuading people at conferences, and that didn't work. Nobody in the industry was interested in the change. And I tried.
Yeah, moving forward, like, is there a motivation?
DARPA, the Center of New Ideas in Washington, put out a program 10 years ago. But again, it was ignored. And because they didn't want to do it, the big players, the digital democracy, the digital dictators, dominated the way the work went, and we achieved nothing with it. So now it's my opinion that the only way we'll get a solution is if the government creates, just like they did for COVID, a competition that they fund. It's not expensive, they can afford it, and we need it. But they create what I call a Lambda Calculus vaccine, which is the computer that actually does it right. And they issue that just as they did the vaccine, free, so that people adopt it and use it. And then the momentum of success will drive the rest of the solution.
As AI grows more powerful, and it's growing more powerful, what ethical frameworks are needed to ensure it serves humanity, not just corporations or politics?
I don't believe ethical standards will solve this problem. I don't believe legislation either in any country. First of all, I don't think you could even get them to all agree what ethical standards really means. It's bad enough already in the US alone trying to agree what ethical standards mean. And whatever time it takes, things just get worse. The only solution is a scientific solution built into the computer hardware.
Can you expand on that a bit? What's your vision for thriving digital democracies in the age of superhuman AI and cyber threats?
Okay, so nature's process of computation is cellular and atomic, and we have to build our software the same way, where every atomic element, every A, B, C, equals, plus, minus, every symbol in cyberspace that can be big or small, there are abstractions. Each one has to be given security, like an egg needs a shell to be able to grow. Every atomic function in cyberspace needs to be protected. And the technology is well known. It's been around for ever since the 60s. It's called capability limit addressing. And now instead of addressing memory physically, you address memory by ideas. Each idea has a name, and each name is protected. It's the only way we can secure cyberspace.
If there was one takeaway you want listeners to remember from the fate of AI society, what would it be, and how can we all contribute to a safer digital future?
Well, it's a big take.
Yeah, very big take.
Education is an essential part of it. That's why I wrote my trilogy. I try to capture the idea that people who are not experts can understand. It's not going to be difficult. It's not going to be easy for them to understand it. But the basic message is we need industrial strength computer science that doesn't allow malware or ransomware to impact the design, that doesn't include a centralized operating system, which is a recipe that will only lead to increased authoritarianism within the operating system itself to stop malware, but becomes the prison for society. And eventually, this digital dictatorship in cyberspace overwhelms normal government, because in the end, everything will be automated by software, everything. How you vote, how bills are passed in Congress, how laws are enacted. The police can't help you.
Mm-hmm. What's the first step we need to take then?
Well, my first step is to publish these books. The second step is I would hope that you will get comments from everybody who listens. I assume that the comments can be sent to you or sent through your channels, and that we can begin a conversation that will involve the population at large. Because unless the population demands improved computer science, nobody will do anything about it.
Ken, thanks for joining us. It was a real pleasure, and you've given us a lot to think about.
Well, it's a challenge, but I'm optimistic. I believe it can be done.
And for our listeners, thanks for joining us on the Future of Cyberspace, brought to you by Brightwork Books. We've explored the urgent need for digital reform and democracy in the age of AI with Kenneth J. Hamer-Hodges, author of The Fate of AI Society, Civilizing Superhuman Cyberspace. If you enjoyed this, please subscribe, share, and leave a review. Grab the book on Amazon or Barnes & Noble. Until next time.